Hey there, I'm Professor McBride, labor nurse, OB instructor, and your guide to everything OB. Let's get to it. Welcome to Everything OB Math Edition. Grab a paper and pencil and let's get started. These are the conversions and formulas we may be using. We are going to focus on weight-based dosing. Let's start with heparin. The doctor orders for your patient to start an IV heparin drip at 16 units per kilogram per hour. You're supplied with a bag of heparin that reads 12,500 units in 250 milliliters. The patient weighs 198 pounds. What is the infusion rate you will set the IV pump at in milliliters per hour? Round to the nearest whole number. First, let's convert the weight in pounds to kilograms. To do this, divide the pounds by 2.2. 198 pounds divided by 2.2 is 90 kilograms. Next, let's determine the dose by multiplying the units ordered by the weight in kilograms. 16 units times 90 kilograms is 1,440 units. This is our dose. Now that we have our dose, we can use desired over half times volume to solve this. 1,440 units divided by 12,500 units times 250 milliliters in the bag equals 28.8. But notice it says to round to the nearest whole number. So we're going to look to the number to the right of the nearest whole number, which is the one right after the decimal. And we see that this number is an 8. If the number is 5 or higher, we will round up. Therefore, the answer is 29 milliliters per hour. Let's try another one, this time with dopamine. The doctor orders 10 micrograms per kilograms per minute of dopamine infusion. The patient weighs 176 pounds. Dopamine is supplied as 500 milligrams in 1,000 milliliters. How many milliliters per hour will the nurse administer? First, convert the weight in pounds to kilograms. To do this, divide the pounds by 2.2. The patient weighs 176 pounds. Divided by 2.2, we find that the patient weighs 80 kilograms. Next, determine the dose by multiplying the micrograms ordered by the weight in kilograms. 10 micrograms times 80 kilograms equals 800 micrograms per minute. Since the medication is supplied in milligrams and the dose is in micrograms, convert the dose to milligrams. To do this, we need to divide the dose in micrograms by 1,000. 800 micrograms divided by 1,000 equals 0.8 milligrams per minute. Next, consider the time. Since the medication is dosed per minute, but our infusion rate runs in milliliters per hour. Therefore, we need to multiply our dose by 60 minutes because there's 60 minutes in an hour. 0.8 milligrams per minute times 60 minutes in an hour equals 48 milligrams per hour. Now this is our dose. Now that we have the dose, we can use desired over half times volume to solve this. 48 milligrams divided by 500 milligrams times 1,000 milliliters equals 96 milliliters per hour. Let's look at one with glucose gel. A baby is born to a diabetic mom weighing 3,500 grams, which is 7 pounds, 12 ounces. The neonatologist orders glucose gel, 200 milligrams per kilogram buccally to treat hypoglycemia. The tube of glucose gel contains 15 grams in 1.25 ounces. How many milliliters of glucose gel will the baby receive? First, let's convert the weight in grams to kilograms. To do this, we need to divide the grams by 1,000. 3,500 grams divided by 1,000 equals 3.5 kilograms. Next, determine the dose by multiplying the milligrams ordered by the weight in kilograms. 200 milligrams times 3.5 kilograms equals 700 milligrams. This is the dose. The medication is supplied in grams per ounce. We need to administer in milligrams per milliliter. So we need to convert grams to milligrams and also convert ounces to milliliters. First, convert ounces to milliliters by multiplying the ounces by 30. 1.25 ounces times 30 equals 37.5 milliliters. This is now our volume. Also convert the glucose gel grams to milligrams by multiplying the grams by 1,000 to match the dose. 15 grams times 1,000 equals 15,000 milligrams. So the glucose gel, having 15 grams in 1.25 ounces, also converts to be the same as saying 15,000 milligrams in 37.5 milliliters. Now all of our math matches. So now we can go back to what our dose was. Remember, our dose was 700 milligrams. Now we're going to use desired over half times volume to solve. What we want is 700 milligrams. That's our dose. What we have is 15,000 milligrams, and our volume is 37.5 milliliters. So when we do 700 milligrams divided by 15,000 milligrams times 37.5 milliliters, we find that the baby will receive 1.75 milliliters of glucose gel. Let's do another one with Lovenox. The doctor orders 2 milligrams per kilogram of Lovenox subcutaneous daily. The patient weighs 155 pounds. You are supplied with a Lovenox syringe that reads 40 milligrams in 0.4 milliliters. How many milliliters per dose will the nurse administer? Round to the nearest tenth. First, convert the weight in pounds to kilograms. To do this, divide the pounds by 2.2. The patient weighs 155 pounds divided by 2.2 equals 70.45454545, and it continues. Do not round here. We want to wait and round at the end. So this is a good problem to leave that whole number full on your calculator and move to the next step. Next, determine the dose by multiplying the milligrams ordered by the weight in kilograms. So the milligrams ordered is 2 milligrams times the weight in kilograms. So 2 milligrams times 70.45454545 equals 140.90909090. Still do not round. Now we have the dose and we can use desired over half times volume to solve. So our desired is 140.90909090 milligrams divided by 40 milligrams times 0.4 milliliters is our volume. And we find that the answer is 1.409. We need to round to the nearest tenth. So the tenth is the first number to the right of the decimal, and we're going to look at the number beyond that to decide if we need to round up. So that number needs to be 5 or greater in order to round up, but that number in the hundredth spot is a 0, so we will not round up, and our total is 1.4 milliliters. Let's try one more with clindamycin. The recommended dosage for clindamycin oral suspension is 8 to 25 milligrams per kilograms per day in 4 divided doses. The child weighs 66 pounds. What is the maximum dose for 24 hours? What is the maximum milligrams per dose? First, convert the weight in pounds to kilograms. To do this, divide the pounds by 2.2. The child weighs 66 pounds. Divided by 2.2 means the child weighs 30 kilograms. Next, determine the maximum dose by multiplying the maximum recommended milligrams by the weight in kilograms. So we can see that the maximum was 25 milligrams times 30 kilograms equals 750 milligrams is the total maximum dose for 24 hours. Finally, divide the total daily maximum dose into individual doses. So it is 4 divided doses. So we will do 750 milligrams divided by 4 doses and find 187.5 milligrams per dose. Thanks for watching. Be sure to subscribe, like, and share for new videos every week about everything OB. See you soon.